Hi everyone and welcome back to Elite Sheets. In today's post, we're diving deep into a significant security vulnerability affecting Apache Tomcat CVE-2025-31650. This flaw can allow a remote, unauthenticated attacker to perform a denial of service attack, essentially crashing your web server and making your applications unavailable. It's a serious issue, and understanding how it works and how to defend against it is crucial. We'll break down the technical details, explore the public exploit known as TomcatKiller, and most importantly, discuss how you can protect your systems. The vulnerability lies in how Tomcat version 10.1.39 handles the HTTP2 protocol, specifically the stream prioritization feature. HTTP2 allows multiple requests or streams to be sent over a single connection. Clients use priority frames to tell the server which streams are more important. The TomcatKiller exploit, authored by Zytax and found on ExploitDB, abuses this. Instead of sending valid priority information, it floods the server with a massive number of intentionally malformed priority frames. The vulnerable Tomcat instance tries to process this garbage data, leading to a rapid consumption of server resources, particularly CPU and memory. This eventually causes an out-of-memory error and crashes the entire Tomcat service. It's crucial to understand that reproducing this should only be done in a controlled lab environment, as demonstrated in our blog post set of notes. So, how can you tell if you're under attack, and more importantly, how can you defend against CVE 2025-31650? Our blog post provides detailed hunting queries for popular SIEM and EDR platforms like Splunk, Kibana, and Microsoft Sentinel. You should be looking for unusual spikes in traffic from a single source IP address, and specifically for the user agent string TomcatKiller if the public exploit is being used. When it comes to defense, the absolute priority is to upgrade your Apache Tomcat instance to a version higher than 10.1.39. Beyond patching, implementing rules on your web application firewall or load balancer to rate limit requests and block the TomcatKiller user agent can provide an immediate layer of protection. For a more proactive approach, consider deploying intrusion prevention system signatures that can detect the pattern of malformed HTTP2 priority frames. Now, to give you a quick illustration of the attack in action, we have a vulnerable Tomcat instance running in our lab environment. On this side of the screen, we'll use the TomcatKiller exploit script against it. Remember, this is for demonstration purposes only and should never be done against systems you don't own or have explicit permission to test. As you can see, we execute the script, and almost immediately the Tomcat server becomes unresponsive. The web browser shows a connection error, and if we look at the server's resources, you can see a massive spike in CPU and memory usage, leading to a complete service disruption. This demonstrates how quickly and effectively this vulnerability can be exploited. In conclusion, CVE 2025-31650 is a critical vulnerability that demands immediate attention. Upgrading your Apache Tomcat instances is the most crucial step you can take to protect your infrastructure. By understanding the attack mechanism and implementing the detection mitigation strategies we've discussed in this video and detailed in the blog post, you can significantly reduce your risk. Make sure to check out the full article for all code snippets and further details. Thanks for watching and stay secure.